Good morning, this is Ms. Billerbeck, and we're going to talk about 7.3 angle properties of special quadrilaterals. So first I'm going to show you a little resource in your workbook that's pretty helpful. All right, so you have angle properties of special quadrilaterals. So we have a parallelogram, we have a rectangle, we have a rhombus, square, and trapezium. Okay, so first we have the properties here. So it has at least one pair of parallel sides. Well, they all do, because even a trapezoid has parallel bases right here. Okay, it has two pairs of parallel sides. Well, that rules out the trapezoid or trapezium. So then we're down to just the parallelograms. So each one of these are parallelograms. So this is the mother parallelogram. We have a special parallelogram with right angles, which is a rectangle. A rhombus is a very special parallelogram with all its sides are congruent. A square is the most specialized. It has right angles and all the sides are congruent. Okay, so now let's look at this. So it says its opposite sides are equal. Well, that's all parallelograms have opposite sides are equal. So this side equals that, this side equals that. Okay, it has four sides that are equal. Well, that's just the rhombus and the square. It has four right angles. Well, that's just a rectangle and a square. It has its opposite angles are equal. Well, that's all parallelograms. Its diagonals are equal. Well, that only works for the special parallelograms with right angles, which is the rectangle and the square. Its diagonals are perpendicular to each other. This is a really cool thing, but it only happens if all the sides are the same, which means it only happens in a rhombus and a square. So the diagonals intersect at right angles. Its diagonals bisect each other. So that's just a quality of a parallelogram. And its diagonals bisect its interior angles. That's really special with a rhombus and a square. There is one shape that has diagonals that intersect at right angles and it's a very special shape. It's called a kite. So that is another type of shape, and it looks just like a kite that you would fly in the sky. And those diagonals also intersect at right angles. Okay? And one thing that's not included in here, that with a parallelogram, with parallelograms, your adjacent angles add up to 180. And that's because adjacent angles in a parallelogram are consecutive interior angles, which we talked about yesterday. So, or same side interior angles, which we talked about last lesson, not yesterday, but last lesson. And that means they're supplementary, so they add up to 180. All right, so let's go back to the lesson now. All right, so we have PQRS is a parallelogram, so we want to find X and Y. Well, we know that the opposite sides of a parallelogram are equal, so we know that we can set it up 3x equals 21, divide by 3 to get x by itself, and we get x equals 7. We also know that the diagonals bisect each other, which means bi is 2 and sect means cut. So bisect means to cut in two, which means this equals that. So we're going to set that up. 3y plus 2 equals 5y minus 10. So we're going to subtract the 3y here using an additive inverse, and we get 2 equals 2y minus 10, add 10 to both sides, and we get 12 equals 2y. Now, when we divide by 2 on both of those, with both of those terms, we get y equals 6. So 2 times 6 would be 12. So our answer then is going to be x equals 7, y equals 6. We can check really quickly. 3 times 6 is 18, plus 2 is 20. 5 times 6 is 30, minus 10 is 20. X is 7, so 3 times 7 is 21, which makes sense. So there we have it. All right, let's look at the next examples. So we have A, B, C, D is a parallelogram, so we want to find X and Y. Well, we know from that little list we were looking at that opposite angles are congruent. So X is just going to equal 110 degrees. Okay, so we also know that, let's see, this is 40 degrees, so if that's 110 degrees, we know how many degrees are in a triangle, 180. So y would be 180 degrees minus 110 degrees minus 40 degrees. So that's going to equal 180 minus 110 is 70. 70 minus 40 is 30 degrees. So 40 plus 30 is 70, plus 110 gives us 180. So that's how we would figure out x and y. So now let's look at quadrilateral FGHI. It is a rectangle. So that tells us we have right angles. Okay, so find x and y. All right, so if they're right angles, that means x, here we go. This adds up to 90 degrees. X plus 61 degrees should equal 90 degrees. So we subtract the 61 from both sides, and we get x equals, and this would be 929 degrees. Okay, so now we have to figure out, well, what is y? Well, one thing we know is that these are equal, these diagonals are equal. They also bisect each other. So this essentially, right, this here is an isosceles triangle. So that means that this is 61 degrees as well. Okay, so we know that this, if I add up 61 plus 61 and subtract it from 180, I'll get this angle here. But this angle is the same angle as y because they're vertical angles. So I can say y equals 180 degrees minus 61 degrees minus 61 degrees. Okay, so that gives me 180 minus 122. So y ends up being, so that's going to be 8. And that gives me 58 degrees. So double check that, 58 plus 22, that gives me 60, 80, so it's 180. All right, so our answers then are x equals 29 degrees, y equals 58 degrees. And there we have it. Okay, next example. So we have quadrilateral PQRS is a rhombus. Oh, rhombuses are really cool. They have all their sides are equal, but they're like a box that someone just kind of pushed over so it doesn't have right angles anymore. But the sides are all equal. We also know some special properties about how these diagonals interact so we can figure out what C is. Okay, so first of all, Z is the easiest. We know rhombi, they intersect at 90 degrees. Those diagonals intersect at 90 degrees. So that was easy. If we look at this, this is actually, these are parallel lines right here. And if those are parallel lines, this is the transversal right here. So we have alternate interior angles going on here. So y equals 65 degrees. All right, so we have x still to find. So we need to figure out what that is. So we know that y is 65. And we know that these are bisected, so this is also 65. And that's 65. So we have two things that we know. All right, so that means that we have an isosceles triangle. We also can add this up to 180. So x is going to be 180 degrees minus 65 minus 65. Okay, so that means x equals 180, and 65 minus 65, that's minus 130, which means x is 50 degrees. So we have x equals 50 degrees. There we have it. Now, if we add up these two, actually, we can do it from here. So we have the parallel lines here. These would be same side interior or consecutive interior. So if this is 130 degrees right here, and that's 50 degrees, that adds up to 180. So they are supplementary angles too. So there's a couple ways you could go at that one. All right, so this one we have ABC is a square. So we have all right angles, all sides are equal. Triangle ABC is an equilateral triangle. Okay, so find the measure of AED. So AED is right here. We also want to find X and Y and Z. So if this is an equilateral triangle here, then that means X equals y equals 4 meters. Okay, but if y is 4 and this is a square, then we know z is also 4 meters. Okay, so then that means that this and this are the same, which means that these two angles are the same. Okay, and we know that an equilateral triangle adds up to 180, but all of these angles are congruent with an equilateral triangle. Okay, so we can find these angles, let's call them W. So these angles W are going to be, let's say 3W equals 180 degrees. So we divide by 3, and we get W equals 60 degrees. Well, if that's 60 degrees, then let me put W right here because I need that little spot right here. So if this is 60 degrees and we know that it's a square, so it's a right angle, that gives us 30 degrees right here. So that's 30. And these two measures here have to be the same. So angle AED has to be equal to angle ADE. Okay, so let me give this, if this is W right here, let me give this angle called V. So that's also V then. So we know that that adds up to 180. So we have 180, 180 degrees equals 2v plus 30. So we subtract the 30. And I'm going to erase this right now. We'll put w equals 60 degrees here. So that gives me 150 equals 2v. So when I divide by 2, I find out that v equals 75 degrees. So v, which is the measure of angle AED, equals 75 degrees. And there we have it. So I hope you have a wonderful day. Bye-bye.